Hey, hey, hey. Okay, so besides being able to describe and compare data, which is where we're getting to, and using socks, we also need to be comfortable with various different displays and honestly, even how to make a couple of them. So, we're going to spend time today down here in the addendum on just common displays, so making sure that you are aware of some key features of each. So, bring your highlighter and go all the way down to the very back. Jeez Louise, don't get motion sick. Okay, here we are. Yay, we have arrived. So go ahead and grab a highlighter and we're going to be going through each of these. So for dot plots are very simple. It's awesome because you can always see all of your data values. Just one, and it's very organized and neat. You can do back-to-back ones. So if you have two things you want to compare, one class and the other, kind of nice and organized, you can easily kind of see, all right, this one's kind of similar across the board. It just makes easy look. One thing that people typically do mess up on, and that is that you don't skip unused values. So for instance, you'll see like here, there are no 2's. That helps you to see how spread out things are. Same over here, like if you're using your number line, like you leave unused ones, it helps you to see kind of the spread. Okay, histograms are also super helpful. We use histograms quite frequently. Again, they have some sort of number line. I think it's really nice when the numbers like directly in the middle, like you see 1, 2, 3, 4, 5, 6, 7. Same with over here. You'll see, honestly, the number line is a little bit messed up. I mean, it's not messed up, but if we're looking at this one, this really right here is like 0, 5, 10, 15, 20, 25, 30. I feel like it's kind of, the number line somehow like got scooted, so sorry, feel free to scooch those. This is nice when your data is, more spread out. You can make these things called bins. So a bin is kind of just a range of values. Always start at this and it goes up to the next one. So this bin right here contains 0 up to like 4.999, right? And then this next one is 5 up to like 9.999, you get the point. Or this one is 10 up to 14.999. So it's always like, and maybe we'll just do one other one, 15 to 19.999. So those are kind of the bins. It helps to like kind of condense it down if your data is all over the place. So that's kind of helpful. Again, the frequencies are always on the sides to show you how many are in each of those. So like if you looked over here, we would know that that's 1, this would be 3 and that, and this would be 4. So it kind of helps you with whatever. What else do we, generally speaking, this is kind of good to look at. There's no spaces between the bars. They're always butt up right next to each other. And again, if something's not used, you would just leave a gap there. So we kind of see that there are like these totals over the sides for counts or frequencies, but we also can see terms of relative frequencies, like out of, like this would be like 10% of them are in this category, 40% are in this one, so that's not terrible. And again, side-by-side histograms are sometimes used where they have like the same bottom, so you can kind of compare them and be like, okay, it looks like there's more in this category than there are over here, and this is where the most are. I think that's all you need to know about histograms. But again, what I would understand is that these are called bins. This is kind of important. Okay, next but not least, okay, bar graphs. Oh, something else we should be stating as we're going along here. Different ones of these are for different things. So this is for numerical data. This is also for numerical data. I mean, this is already at the top of your notes as well. Over here, bar charts are used for categorical data. So just looking at these, something that's a little bit different with them is that there are strictly bars. You have, I'm just being extra right now because, like, why not? It's fun to be extra. I need it to be matchy. Okay, so down here you have your categories on the bottom. I mean, you've definitely used these in like elementary school. Again, it kind of shows you can work with the idea of how much there are at the top of each of these, right? Like there would be 10 on this one and so on and so forth. Or you can do percent wise, be like, okay, this is 20% of our data, like vanilla. You can do side by sides like down here just to help for comparison ones. Again, you're welcome to choose like the actual counts of them, but sometimes percents are a little bit easier to compare, especially if there's different amounts of people. For instance, if you look over here, like we have 6 times 3 is there are 18 males versus females, there are 22. So sometimes if you wanted to compare like the counts of them, it's percents make it easy to see there's like a little bit of a difference. I feel like the way that these look, I mean, they're still generally speaking the same, but maybe we say use percents when totals are different. And I just feel like it makes it easier for comparison. All right, so we're going to continue looking at different displays. Ogives are the next ones. They're a little bit different because they are all about frequencies. So if you look on the side here, we're looking at, as you progress through data, the cumulative frequencies, meaning you're just adding up as you go. Think about snow accumulation. So if we go ahead and look at this first section, we see that it is about weekly allowances for different people. So we say that here's all of the amounts of people. If you look at the very top of the graph, that is always the total amount of people that you have. So for this one, skimming across here, I always like to kind of make this kind of thing. There are 36 data values in our set in total. And all of them have an allowance that is 40 or below. So 40 and below leads to 36 total data values in our set. If you were to look at all these other ones, like as you progress, going back to the beginning, for people that have $5 or less, there are 12 people that have $5 or less. Or if we look at this next group, $10 or less, there are 20 people that have that. Or you could even look over here at 20 and say, all right, how many people got $20 or less? And you kind of get the point. So this is $20 or less. So it kind of helps you see as you accumulate through the list. Like, so in this first section, how many people had, there was 12 people in here. And the next one we know that there's 20. So to get from 12 to 20, we added 8 people. And then to get from 20 to 24 people, we added 4. So you can kind of see as we're going, or even here, 24 to 28 also added 4 people. And then we went from 28 to so on. And you kind of progress. If you have this flat line, what do you think the flat line portion of this is indicating? Right, we didn't increase in people. The flat line segment indicates that there were 0 people within that kind of range of values. Again, this asks us to look here. It says 24 people had an allowance of what? Again, we can almost go backwards and find, okay, where's 24? Here's 24 people. Looking over here, when we had 24 people, they had an allowance of $15 or less. And then it says, for this very first segment here indicates how many people had an allowance of $5 or less. Well, there was 12. So it's kind of just a different way of reading. It kind of accumulates across the board. Same with the second one. It says relative cumulative. Remember when we're using the word relative, that is just another word for percent. And then cumulative is just like adding up as you go through the data values. So over here, you'll notice again, if you skim all the way across to the top, this would account for 100%. So we're looking at ages of children. At age 6, if you want age 16-year-olds or less, that is 100% of your data. Now, the first thing asks you to go find the median section. The median section, well, that would be where you perfectly split the data in half, where there's 50% of the data below that point. And so you could just skim over here to find where 50% is. Here's 50% of the data. You hit the point and then you drop a line down. That's around 11. At 11, there's 50% of the data less than 11, and there's 50% of the data above 11. So the median would be about that. Remember, you use an M to represent the median. The next question says, the youngest possible age of a person in the data is what? Okay, so we would kind of maybe start over here and look and say, okay, there's no one that is 2 years old or less. All right, but then maybe I look at this category of 4 years old and less. There is about, I don't know, what does that look like to you? 4 years old or less, there's about maybe 15% of those. But it just asks for what is the youngest possible age. Well, they could be, in this little section, 4 or 3. And so the youngest possible age is 3, right? Because that's the first time we have people. It says about what percent of the people were 9 to 10 years old. So we'd have to find where that is, 9 to 10 years old. Here's 10 or less, but we really just care about this section here. How many people in there? Because this would be 8 and less. So this is like 9 and 10 and less right here. How many people in there? Well, that appears to be, if we kind of just look over here at the percentage-wise, that section appears to go up by 10% of the people are in there. And it says, what percent of the people were 16 years old to 13 years old? So here's 16 and less. So we'd have to figure out where the 13 cutoff is. 13 would be like here. Right, because this would be 16 and less. This would be 14 and less. This would be 12 and less, though, so it continues like this spot. And if you skim over here, I want 16 to 13. Well, that contains about 40% of the population. Oops, sorry. So O-drives are a little bit interesting to read. They deal with cumulative frequencies, but it's kind of nice. Again, just another small note though, like even for this was the median. I want you to take a note about the lower half of the data versus the upper half of the data. Even just looking here, we could say that this is more spread out. And so that would mean that the data is kind of like almost, it's skewed, right? Where it's more spread out on that lower half where the median is. So something like that. So we would end up saying that this is skewed to the left. but it's just kind of a different way of perceiving information. So let's give these a look. Stem and leaf plots. Things that you need to know. Everything, again, lines up perfectly in order. You don't skip unused stem values. So like, for instance, here, I don't have anything in the 18 category. I'm just going to leave that. It's going to help us see how spread out the data is. Something else that's always pointed is you're always the leaves. So maybe we record this part right here. This would be considered the stem. And this would be considered over here the leaves. The leaves always have a single digit in them. Again, depending on what your key is going to tell you what you're looking at. So you could use a key, you could make something where it's like, maybe something like, you could have something like that, and that could represent 123. You could have something like that, and that could represent 12.3. It really just depends on what you want. You make it what you want. But you can only have one number behind here. So if you were working with like a really large number, you would have to have like, I don't know, that would be like 1,256.2 or something like that. I don't know, that you get kind of creative with the keys. You can kind of split up the kind of a cool thing for these as you can split the keys to be how, or the leaves to be how you want them to, or the stems. So I would say, okay. If you're splitting your stems the way you want them to, like you over here, they decided to do zeros like 0 to 4 in this one, and then like any values 5 to 9 in the other. That's fine, but again, you have to be consistent. And it's that idea, if you don't have something, you're just going to leave that section blank. It's going to help you see out the spread outness. Again, you would want to do this. Split stems if data is very consistent or close together. So like if you see here, like the data is like mostly by threes. Okay, well we've split up the data into all these little stems, or here we've split it, I don't know. It just depends. How much you want to split it is really just dependent by how close the data is together. And again, these are kind of nice because you can do back-to-back stem and leaf plots really easily by just making kind of one number line and then just putting things on either side. It helps you kind of say like, oh, I can see how Calvert compares to Patuxent at just a glance. Again, the keys for these ones are a little bit different. You have to be able to read it from both sides, but this one would be like 60 this way and then 60 that way, or 67 and then 65, depending how you're reading it. So yeah, those aren't going to be too crazy. We'll definitely work with those, but just being kind of comfortable with reading those keys. All right, the last but not least, and this one is the one that we are going to love so very much. The reason that we're going to love it is because it is based on having the 5-number summary. And if we haven't really talked about the 5-number summary yet, it's just those really important numbers, the maximum, the minimum, Q1, Q2, the median. All of those things help for us to do easily comparisons later. It helps you to see how spread out the data is. It's giving you equal sized groups. Only downside is you can't ever tell how many data values you are. You can just kind of look at what's going on. So looking at this first data plot, I also like using the modified ones more. Those are the ones because you can see the outliers, which are nice, I think, and you can make them on your calculator pretty easily. So this part here represents, would represent your minimum right there at 10. And then this would be Q1. this would be your median, or Q2. This would be Q3. And then this would be your maximum. This is nice because you can see like how spread out. This is a good thing for spread. So you can see, all right, here's 25% of the data. Here's 25% of the data, like in this section. Here's 25%. And here's 25%. And so they are all the same amount, but I would say like this part is the most spread out section in your data. And even if you like to look at like your median, like your middle number here, you can kind of say, all right, yeah, I think the upper half is more spread out as like a total. This whole upper half is more spread out than the lower half of the data. And so we could say that that's skewed to the right because the tail, it's more spread out on that side. So notice just a couple, I mean, these are some key things up here. You're always going to have a number line that's going to help you keep things straight. You're always going to label those 5-number summary on here. And then you're also going to have like your box mixture plot, obviously. And then most of the time there'll be a title of some sort that goes with it, which you can kind of see down here. You have like period 1 and period 2, like testing values. This is still sort of the same thing down here. We've got 25% of the data is in this section. We have 25% of the data over here. 25% of the data is here. And then 25% of the data is right here as well. Where this stops right here, this is your lower bound. Whenever you are making a modified box plot, actually, I lied. That's not your lower bound. That is the next data value. That is, I don't know why I said that. You'd have your lower bound, okay, but it's the next data value that shows up. Data value that is less than upper bound. So you'd have your upper bound as the next one lower than that. So we would know that 40 is the next data value closest to 49. Cool. And again, you can kind of just see that we have that little outlier floating further away. Again, maybe if you want to keep track, this would be your minimum. This would be Q1. This would be your middle. This would be Q3. That's just going to be your next data value, and then this would be your maximum over here. Again, looking at this, it appears that if you kind of look at the middle, to me, it kind of looks that your lower half of the day, I mean, it's kind of symmetric, about spaced out about the same on both sides. So it's really nice to have these 5-number summaries and then be able to comment on the spread. You can easily find IQR. This box plots are just really nice to work with. Parallel box plots, again, make for good comparison of things. You just put them on the same number line and just line everything up, and you can kind of see, okay, here's their middle number, and that's how that compares, or this one appears to be more spread out than this data set, and it just makes for good stuff. So we're actually going to make a box plot together in the next video, but for right now, that is all that I got.